What's happening, Year 10? Sorry about not being able to do the live lessons there. As I say, I'm in school today, interviewing for a new post starting in September for a new teacher coming in. Okay, so we will do this the way that we've done all our live lessons, and I'll be able to catch up with you tomorrow and Thursday on the live lessons, obviously before we start back again next week. Okay, so today's rule is the fourth sort of circle theorem that we're going to look at, starting to get a little bit more complex. And it's to do with something called cyclic quads. Now, a cyclic quad basically is just a four-sided shape where we've chosen 4 points on the circumference of a circle, and they form the 4 corners or vertices of our quadrilateral. Okay, and whenever that happens, what we find is that the opposite angles, so that one and that one, add up to 180, also that's obviously equals 180 there, aren't I? And this one, opposite angles, add up to 180. Okay, that's the rule. Opposite, add up to 180, opposites, add up to 180. That's all you need to be able to do. Okay, so first one, diagram shows a circle with centre 0, ABCD line the circumference of the circle. It's probably going to say that for every single one that we do. ACD equals 62. So A to C to D, A to C to D is 62. So that one there is 62. And BAC is 94. B to A to C is 94. So that one there is 94. Figure out ABD. So A to B to D is this one. So it will be opposite to 62. So to figure out this one, I'll do 180 minus 62, which is 118. And to figure out BDC, B to D to C, well, that one is opposite the 94. So that'll give me 86. Okay, so if you pause the video now, please, have a go at your question 1 and question 2. And then come back when you're ready. Okay. Right. Hopefully you got those ones right. Let's have a little look at question 3. So again, diagram shows right. ADC equals 53. So A to D to C is 53, and BCD, B to C to D is 81. Evaluate angles A to B, ABC. ABC is this one here. So that is opposite the 53. So ABC is 180, take away 53, which is 127. And DAB, D to A to B, it's this one up here. That's opposite the 81. So that's 180, take away 81, which is 99. Okay, so exactly the same thing again there, except just kind of switching around which angles they're giving you and which ones they want. So all you need to do, again, I probably don't know if you'd have to sketch it or not. If you can hold it in your head and think, yeah, it's that one, basically you're just always taking it away from 180. That's it. Okay, so have a go at questions 3 and 4, please, and then come back when you're ready to continue. Okay, right, question 5, and the last sort of 4 of them, 5, 6, 7, 8, get a little bit trickier. Okay, so this time we're told that this is a straight line and this is a straight line here. Okay, now what we can do from that one, if I just kind of zoom in a little bit there, oh, it's that one. There we go. Okay, this is still a straight line, isn't it? So it means that that angle inside there, which is the one inside the cyclic quad, that angle in there will be 180 take away 76, which is 104, and that's because of angles on a straight line. Okay, you don't need to kind of write this down. This isn't actually the answer for these bits, but it is important. Okay, and this one here, this angle there, is going to be 75, and that's 75 because vertically opposite angles are equal. Okay, so I'm being asked to evaluate DCB. This one was 104 there, wasn't it? So I want to figure out this one. That is opposite the 75. So DCB will be 180, take away 75, which is 105. And C to D to A, which is this one up here. I want to figure that one out. That is opposite the 104. What's it called? CDA. So I'll do 180, take away 104, and that gives me 76 for that one. Okay. So what you're doing there is, instead of being given two of the angles inside the cyclic quad and being asked to figure out the other two, you're being given enough information to be able to calculate them quite simply using old angle rules that we've been doing since you were in year 7. Angles on a straight line out to 180, vertically opposite angles are equal. So that's 75 because of that. That's 104 because of that. Now that we know those two angles inside the cyclic quad, we can use our circle theorem to calculate them. Okay, so pause the video, please. Have a go at questions 5 and 6, and then when you're ready, come back and we'll finish off questions 7 and 8. Right, so hopefully everyone's got everything right up to there. Now, the diagram shows a circle with centre. Okay, this time lengths AB and AD are equal. Okay, so lengths AB and AD are equal. That one there is the same as that one there. And lengths BC and BD are equal. So that one and that one are equal. Okay. That means that we've got two isosceles triangles there, haven't we? Okay. And I want to be able to figure out angle CBD. I want this one there. Okay. Which means that I need to know an angle inside this triangle. I need to know either that one or that one. Okay. So let's think about what we can figure out first. Well, if this is an isosceles triangle here and it's already pointing up, it means that the two bottom angles here are going to be equal. So that and that are the same. Okay, and the reason they're the same there is because it's an isosceles triangle, nothing to do with circle theorems yet. If that's 42, then I can do 42, add 42, which is 84, and I can do 180, take away 84, which gives me 96. So that angle up there must be 96. Okay, that is just working in that isosceles triangle there. It's effectively ignoring the bottom part of the diagram. Okay, because it's an isosceles triangle, two angles at the bottom of the equal sides are the same, and they add up to 180. So I know that one. Now I can look at the cyclic quad, because that cyclic quad that goes from A to B to C to D, I now know one of the angles in there, which means I can figure out the angle opposite that one. So I can figure out this angle down here. So angle BCD will equal 180, take away 96, which is 84. Okay. Now, if that one there is 84, what I'm going to do is I'm just going to turn that final isosceles triangle, the green one on my diagram, so it's pointing up. If that's 84, it means that that one in there is 84 as well. Okay, so I'm going to do 84 plus 84, which is 168, and then I'm going to do 180 minus 168, which is 12, and that must be angle CBD, because that's the leftover angle in there. Okay, so that one would be quite a tricky, maybe 4 or 5 mark circle theorem question there. I'll just go through that all again. Okay, in fact, it might be worth, if you can, just while I'm going to talk through this, get your question 7 up so you can see what you're going to do. We're given that side and that side are the same, and that side and that side are the same. The reason, by the way, that I put the extra little line there and there is to say that those two are the same as each other, but that one is not the same as those two. So that's a pair, them two there, and that's a pair, them two there. So because this is an isosceles triangle with those two being the same side, it means that that 42 appears over there as well. And now I know two of the angles in a triangle, so I can add them up, take it off 180 to figure out the third one. Then that is one of the angles in the cyclic quad, which means that I can figure out the opposite angle, which is here in that cyclic quad. There's your cyclic quad like that, basically ignoring that middle line, which means that the opposite angle from that is the bottom one. So if I do 180, take away the top one, it gives me that the bottom one's 84. And then I was looking at this other isosceles triangle here, and I've done it like that. If that's 84, then that's got to be 84. Okay? And if I know two of the angles are 84, add them up to get 168, take it off 180 to give me the missing one, which is what I was after all along. So that must be 12. Okay? So can you have a go, please, at questions 7 and 8 on your task? And then that's us done for today. Okay? Do apologise about not being able to do this in person again, but I will catch up with you tomorrow and on Thursday. Okay? And then obviously this time next week we will be in school. Okay? So well done. Next one.